Okay, hi class. So finally makarecord na yung lecture. So this is lecture 12. Yeah, 12, no? Under the polynomial curves. So let's discuss the increasing and decreasing functions using the first derivative test. So kani nga mga topics class under polynomial curves, no? Kani ga partner man ni siya. Kini po siya partner and kini siya partner. Okay? So let's discuss the first derivative test and how is it used or unsa iyang implication, no, with regards to the behavior of your functions, whether or not increasing siya. Okay, so let's go to the definitions of increasing and decreasing functions. So this is very class explanatory, no? When you say increasing, a function is increasing on an interval if for any two numbers x sub 1 and x sub 2 in the interval daw, okay, defined by a certain interval, arbitrary lang na interval, no? And when your x sub 1 is lesser than your x sub 2, no? So, trita focus, okay, implies that your f of x sub 1 or the y coordinate na pare sa x sub 1 is lesser than your f of x sub 2. So, basically, nga na siya itsura class. Your x sub 1 is less than x sub 2. Okay, so na siya sa left, no? So, as we move to the right, your function is increasing. Why? Kaya ang imong f of x sub 1, so partner sa imong x sub 1, kani nga point, is lesser than your f of x sub 2 kani nga point. Okay? So kung kana ang behavior sa imong two arbitrary points, then we can say that it is increasing from your x sub 1 to x sub 2 or as we move to the right. Okay, very self-explanatory. And decreasing is of course the opposite. Same lang yapon, x sub 1 is less than your x sub 2, kana siya. However, the difference is that your f of x sub 1 is greater than your f of x sub 2. So, imong x sub 1 nasa taas, mas dako siya value as compared to your f of x sub 2. So, given na ng two arbitrary points nga itong gi-assume, tanaw na itong behavior from the first point to the second point, then it is decreasing. It moves down yung value, no? So again, nasa note diri, a function is increasing when as x moves to the right, okay? Paano na to ang pagtanaw sa graph, no? The graph moves up, okay? Move up siya dira. That's increasing. And decreasing siya when the graph moves down, okay? So, how do we determine na in class the behavior of the graph? Kung increasing ba siya or decreasing? Using the knowledge nga nag-gain nato, no? Since midterm sa derivative. So, say for example, you have this graph, no? There are three parts of this graph and each part has a different behavior, okay? So, starts at the diri class, I'd like to emphasize lang first ang kining sa middle part, which is a constant value, no? So, from x is equal to a, again, arbitrary points rin itong gikuan. So, kani mong a, and then kani mong b, no? So, makita nimo from a to b daw class, nga x value. Your y is a constant value. Okay? So, constant value siya diri. We can assume that this is a piecewise function, no? So, from a to b, your y is a constant value. So, unsa man ay imong derivative when you have a constant value? Of course, you have a zero values imong derivative. Okay? Because again, ang imong tangent line is na siya for the whole for all the points in this part of the graph. Okay, so your tangent line is a horizontal line and so the slope will be 0. Okay, ato ta diri sa imuhang left part sa graphs, no? From 0 to a. So your graph is decreasing, no? Kabalo naman ta sa definition sa decreasing. As we move to the right, as x moves to the right, our graph is moving down. So it is decreasing. And ang implication ani class is that your derivative is always gonna be negative. Nga naman, kay the tangent line, whichever ang point gani sa graph class, will look like this. Kung naa siya ani nga point, ana iyahang tangent line. Kung naa diri, ana. Kung naa dira, ana siya gitsura. But, maskin lahi-lahi na siya value sa iyang slope, the common characteristic ana sa iyahang slope sa tangent line is that it is a negative value. That's why your derivative here is less than 0, it indicates that that is a negative value. Okay? Mo nang emphasize ko dira. Slope is negative because the tangent line is going down. Okay? So again, maskin asa nga point ana, although your tangent line will look different from one point to another, but the common thing is that the slope will always be a negative value. Siguro diri a negative higher value no in kuan. For example, probably this is -5 and this is a little lesser no than this. For example, this is -2, but again, both or all the derivative of this part of your function is a negative value. Okay? And opposite po siya sa imuhang kini nga part sa imong graph, which is an increasing part sa imong graph, no? So from b to positive infinity, as we move to the right, as x moves to the right, now we can see that the graph is moving up. So therefore, the tangent line will look like this. So example, kini nga point ana, yang tangent line diri ana and diri ana. Okay? So again, they will have different values, but the common is that the slope is a positive value. Okay? So because ang imuhang line will always look like this or move up siya. So again, emphasize na ko nga, if ingani itsura sa imong line, the slope is positive, if ingani negative. Okay, so mao na siya ato ang magamit na concept no when we use the first derivative test or when we want to know the behavior of the graph at a certain interval sa imuhang given ta certain interval, and then ibuak-buakon pag nato na class into different intervals using the critical numbers nga itong na-solve. And then we will know nga from this interval to a specific critical number, increasing ba siya or decreasing, and so on. Okay? So let's go to, mo naman siya ang definition no, ng theorem 3.5. Your f prime of x, again, the derivative is greater than 0 or a positive value for all x in AB. Then, kung positive value ang iyang slope, then makaingon ta nga increasing ang iyang f on that certain interval. Kung negative po, meaning less than 0, this negative value, then it is decreasing. And then if it is equal to 0, exactly equal to 0, then your f is constant at that certain interval. Okay. So, let's go to, hala, anong nangyayari? Medyo nag-error tayo din dapita, class. Okay, so dali na ta sa guidelines for finding intervals in which a function is increasing or decreasing. And why is it important? Because dili man always mo tagano graph, di ba? Ipa-describe man mo unsa kay itsura sa graph at this certain interval, is it increasing or decreasing? And di ba gipapangita sa before the previous lecture, gipapangita mo og critical number and then gipapangita mo extrema at a close interval. But here, class, we're gonna focus on open intervals sa imong function, meaning the entire domain of your function. So, unsa kay behavior sa imong graph at specific intervals of the entire domain. Okay? So, these are the guidelines. First is locate the critical number. So, kabalo naman ta ani. I-locate na to ang critical numbers. Why, class? Because aside from the fact that it could be a possible minimum or maximum sa imong graph, these numbers are used to determine the test intervals. Nga naman, kita kanta may examples. For example, this is your x squared, di ba? And we know if makasolve ganita, class, makuha gid niya itong number as your critical number kani nga point sa imuhang graph. Okay? And ngano makaingon man ta nga this can be used to determine the test intervals. Kay, at this point, I think I've emphasized this sa previous lecture. Critical numbers, aside from they are the possible relative maximum or minimum or the extrema. They could be, it's also a manifestation, kanang critical number at that point, that your graph starts to behave differently. Okay, unsay pasabot na ako. For example, ito, balik ta to. This is your critical number. Dinan ako ng x, y kana. Kani nga part imong critical number sa imuhang graph. Okay, this is also the point where the graph changes its behavior. Kay awa, from here, nag-decrease siya, class. And it's a constant decrease, di ba? Naay kuan ba kanang constant siya nga gapaubos. But kung mo reach aning critical number ni mo diri, it starts to go up. Okay? So meaning at this point the graph starts to change its behavior. Okay? So gamit jud ang critical number kay maskin dili nimo siya ma-find as a possible extrema or extremum, we are sure. The one thing is for sure nga kanang critical number dira nga point mag-change ang behavior sa imong graph. Okay? So maka-determine na ta sa test interval nga naman kung naka critical number diri, ang atong interval will be from negative infinity. Okay, ako na lang na isulat. So for example kana siya, and this is your critical number, no? Kani. Example x is equal to 0 na sa origin. So ang pangitan natong interval class will be atong test intervals kining gitawag na test intervals will be from negative infinity to 0 because that will have a different behavior. Okay, meaning from your end sa imong interval up to the critical number, you will have a different behavior. So tanawa, decreasing siya. And then the other one will be from your critical number 0 up to positive infinity or up to the next interval. So you will also have a different behavior here. Okay, so based sa imong critical number class, mao po na mo determine pila ka test intervals ang imuhang gamiton. Okay, so let's have the second step, which is after you locate makabalo na tayo sa critical number, we will know the test intervals. Next is we determine the sign of f prime of x at one test value in each of the intervals. So balik ta ani nga concept, no? Pag makakuha na tag critical numbers ka, so tanawan nato ni nga graph ha. The critical numbers here will be kani x is equal to a. Okay, kana siya a and kana siya b. So these are the critical numbers. So ang atong interval ani makita nato will be from your negative infinity. Okay, kay mo ana pa man na siya dira, kani pud mo ana pa na siya dito. So from negative infinity to a mo na sa interval, from a to b, and then from b to positive infinity, you will have three different intervals. Okay? Kaya naman kay duha ka critical number, so we can assume that you will have you have two critical numbers. Okay? So that means you will have three test intervals class plus one na siya. You have three test intervals. And for each interval, you will have different behaviors in mong graph. Okay? So for example, negative infinity to A, you will have a different interval, different behavior. So kana. Ang next step dayon is determine the sign of f prime of x. All you have to do, class, is get a random number, random x, no, within this interval, and then get the value of f prime of x, and then tanaw na nimo kung positive ba siya or negative. Dili ta mag-gear sa unsa gid ang value. Kung positive ba siya or negative mo ra importante. Kung negative siya, then makonclude ta nga at this interval you will have a decreasing behavior sa mga function. Okay, so that's why it's important to determine the value or the sign of f prime of x at those intervals, test intervals. And then after that, determine na to increasing ba siya or decreasing. So kung negative yang f prime of x, decreasing. Kung positive, increasing. Kung 0, then it will be a constant value. Okay, so sige, let's have an example. Gisulat na lang ako daan kay para madali po ta class. Okay, so find open intervals on this function daw. Okay? Again, focus sa open intervals and the given tag function. We will know, or we can test if it is decreasing, increasing, or decreasing. So, first is, same sa atong pag-solve before class, in finding the critical numbers, tanaw na to kung kanus mo ma-zero ang imuhang f prime of x. Same gyapon, f prime of x or kano sa siya ma-undefined. Okay? So again, the first step will be differentiating your original function. So if we differentiate this, we will get 3x squared minus 3x. And then, kani siya is a polynomial man. There will be no chance for it to be undefined. So ato lang siyang i-equate to 0. So you will have two factors, which is 3x and then nakay x minus 1. So you will have critical numbers nga 0 ug 1. So this values dayon class. Of course, taga naman ta mo graph dire. Pero kung wala pa mo kabalo, pwede mo mag-imagine lang sa number line, no? As I always discuss in class. So if this is your 0 and this is your 1, because those are the critical numbers, meaning wala pa takabalo sa behavior class if these numbers are minimum or maximum, di ba? Pero we can assume na dayon the interval. So kaya di ba naingon ko, the critical numbers kaya dira ang point sa imong graph where it changes its behavior. So that means the left of this critical number will have a different behavior. Okay? So mag-define the interval there, which is from negative infinity to 0. Okay? And then between your critical numbers, lahi po ng behavior sa mong graph. So nata isa ka interval nga 0, 1. And then again, katong last ni mong critical number, which is 1, 1 to positive infinity, you will have different behaviors sa imong graph. Okay? So, emphasis lang po na ako, kaning mga critical number, mao po nang imong endpoint sa imong interval class. Pero dili siya included sa imong test. That's why you have open and close parenthesis nga notation. Okay? So, kaning again, 0, 1 will be the endpoint sa imong mga intervals. Okay? So, kung tanaw na to sa graph, of course, makita naman natin sa behavior kay gitagaan naman tamo. Pero, assuming wala pa mo kabalo, so, pwede na to tungaon into 3 intervals. Ito ang i-define ganina, kana, o kana. Okay? So, assuming wala pa takabalo nga mo na itsura niya, let's test. For the test value, kamo na bahala class. Basta within this interval. Now, from negative infinity to 0, dili na to pwede tas ang 0 kay open man na siya, open interval man. So, makikita lang ta, akong ginabuhat is katong pinakaduol niya nga value, which is nga whole number. Kung 0 na, of course, within this interval, negative 1 ako pilion. Okay? Ato sa isa ka test value, from 0 to 1, wala man tayo lang value, mag-fraction gid ta, so 1/2 akong kwaon na value. Again, pwede na mo mag-assume any value, basta within aning interval. And then, ang isa nimo ka last interval mo 1 to positive infinity, I'll get 2 as my test value. So again, arbitrary na basta within your interval, you can assume any number. And then after that class, after assuming different values for each interval, you will get the value na of f prime of x. So, kani nga mga values, ato na i-substitute diri sa f prime of x. Okay? So that's why you have f prime of negative 1, you will have 6. And that is a positive value. So that is greater than 0. Positive value. That's why mo conclude ta class nga increasing ang imuhang behavior sa graph at this interval. Okay, hinahinay lang ta. From this interval nga negative infinity to 0, tanawa, we can confirm that it is indeed increasing based atong gitest dire. Okay? Next, for 0 to 1, ang atong gikuha nga value is 1/2. Okay, so we'll get the value of f prime of 1/2. Substitute gyapon dira. So we will get negative 3/4. Negative 3/4. Negative value that is less than 0. So unsa man mo conclude? If it is a negative value sa imong slope or derivative, then the behavior of the graph at this interval is decreasing. So that's why at 0, 1, get decrease gid siya. Okay? Next interval is 1 to positive infinity. So we get 2 as a test value. F prime of 2 will be 6. And 6 is a positive value that is greater than 0. So we can conclude that our graph or our function is increasing at this interval. So indeed, from 1 to positive infinity, ga-increase ang imuhang graph. Okay? So, ingana na siya pag-test class. Ingana na siya papangita if increasing, decreasing ang imuhang behavior sa graph at a certain intervals. Okay? So, ang pinaka-importante, isa sa pinaka-importante, the first step good class is getting the critical numbers. Nga naman, if dili man gud mo ma-define ta ng critical numbers, mamali na na imuhang pag-solve or mamali ang imong assumption sa imong whole graph ba. Okay, kano sa man na siya mahitabo? Example lang, ang imurang na-assume diri kay ang imuhang critical number ha, is kaning 1 lang. Okay, example, kaning 1 lang imong nakuha. Kay ang 0, nalimtan nimo, takabalo, so nalimtan nimo 0. Ang imong critical number kay 1, isa ra ka buok. So, syempre, assuming kabalo ka mo solve anang pag-test nimo diya. So, ang imong nakuha critical number 1. So, pila man ka buok imong interval karon duha ra imong test intervals from negative infinity to 1, Yung isa, 1 to positive infinity. Okay? So, take for example, ang atong gikuha nga test value diri sa negative infinity to 1 kay negative 1 gyapon. Butang na nato. Okay? So, ang atong na-conclude increasing. Sakto. Pero kanang increasing is from negative infinity to 1. So, ang atong assumption ana will be something like this in graph. Pa-increase siya padulong sa 1, dili padulong sa 0. Okay? Increase siya padulong sa 1. Ana lang di ito. Di ba? And then from 1 to positive infinity, butang lang nato mo mong na-test. Same lagi po. Increasing. Okay, increasing. So sakto. Sakto yung mong nakuha diri, increasing siya. Pero ang kini nga part sa graph will be wrong na. Okay, mali naman ang imuhang test intervals. Nakulangan ka ba? So again, ang isa sa pinaka-importante nga step is determining the critical numbers sa imuhang function. Okay, kung naakay isa makulang diya, marong na gid ka. Okay? So I hope that's understandable. Ay, reason na ko nga part siguro. Kinilangan ka na. Okay, let's move on to another example para makita dyan ninyo. Nasa to. Reason ko nyo. Ay, nako. Bala na, basta na ko annotation na. Okay, let's find the open intervals on which the function is increasing or decreasing. This example is to lookable class. Okay, so let's begin with the first one. Isulat na lang ako para madali na sad. Okay, so we have function here, x to the fourth minus 32x plus 4. So, of course, get the derivative. That will be 4x cubed minus 32. Okay, and then again, wala man yung chance nga ma-undefined, pero na yung chance ma-0. So, what are those values? At may equate to 0. Okay? And then getting the factors. So, 4x cubed minus 8. So, kanira, ang puruhan nga ma-0, no? So, x cubed is equal to 8, x is equal to 2. Okay, isa ra iyahang root. Okay, naka-add man ang imong exponent. So, again, isa ra imong critical number. So, kung ako sa inyo, balik-balik kong yung solve, isa ra ba, duha, sa man jud. Especially kung naka-x squared na, no? Duha man na yung roots kung even na yung exponent. Naka-positive and the negative root. Okay, in this case, you have an odd exponent, so isa ra na yung root. So, we have one critical number. So, kung tanaw na to sa number line na sad, again, assuming wala ta kakita sa graph there sa right, so, your number line will be 2 somewhere here. So, you will have para mas ma-visualize niyo, you will have two intervals. You have negative infinity to 2, and then 2 to positive infinity. Okay? So, mauna yung interval. Ana. Okay. So, kung ako sa inyo mas better po mag-tabulate mo para mas dali ninyo makita ba. Okay? So, again, we have two test intervals. For the first interval, atong test value na within this interval, pwede 1, pwede 0, pwede negative 1 na sa inyo. Pero for me, mas dali ang value nga 0. Diba? At least, dali na ako makita, ma-solve. Okay? My test value will be 0 at this interval. So what will be the sign of f prime of x? I will substitute the value of x here, 0 sa imong f prime of x. So you will get negative 32. And negative 32 is less than 0. It's a negative value. So, my conclusion will be, in this interval, decreasing ang imuhang function. So, wala lang ako ni na stretch class, mas maayo na stretch na ako ni nga graph. Pero makita man po ninyo, no, na kung gi-divide na ako ni critical number, kini 2 man na siya, critical number 2. From your negative infinity up to 2, it is indeed decreasing. Okay? For the next interval, magkuha lang kog 3 class, pinakadool nga value sa 2. So f prime of 3 will be 76, which is a positive value greater than 0. My conclusion is that it is increasing at this interval. Okay? Kana lang. And then moving on to the second example. Ay, balik-balik, very good class. Pero again, you have to be careful sa pag-solve. Sige, let's have x to the fourth minus 2x squared. So get the derivative for x cubed minus 4x. Factor, you will have two factors, 4x and x squared minus 1. 4x, x squared minus 1. if you equate it to 0. So, ang first ni mga critical number 0, muna yung gigon ka ganina, you will have x squared is equal to 1. You will have an even exponent. So, that means you will have two roots, the positive and negative one. So, again, kung ma-miss na niyo isa ka root, duhara inyohang or tulura inyohang interval, test intervals nyo ma-consider. So, in this case, you have three critical numbers. You will have four test intervals. So, first is, there is a negative 1. That will be negative infinity to negative 1. The second is, again, kung wala pa takita sa graph, imagine na nato na no, you have 0, negative 1, and 1. So, test intervals will be negative infinity to negative 1 kana. Kana din siya from negative 1 to 0. And then next is 0 to 1. And then 1 to positive infinity. Okay? That's why you have this. Ay, sorry. Kana. Kining upat ka test intervals. Okay, balik-balik lagi sa class no. After determining test intervals, assume some values nga within sa imong interval. So, for the first interval, negative 2 kung kwaon. Kini is negative 1 half. Between 0 and 1, 1 half gyapon kwaon. Between 1 and positive infinity, 2 akong kwaon. Okay. And then substitute these values to f prime of x. So you will get a negative value here, negative 24 for f prime of negative 2. So kung negative value, conclusion will be decreasing. Okay? So that's why kini sa imong first interval here sa negative 1, negative infinity to negative 1, decreasing yun tuod ang imuhang value. Okay? Decreasing. And then the second one will be kani siya nga interval. We get a positive value class, positive 3 halves. So increasing, kana siya increasing. And then next interval from 0 to 1, kana siya interval. So we get a negative value, decreasing. Okay? Decreasing kana. And then finally, the last interval na to, we get a positive value sa f prime nimo. You will have an increasing behavior sa imong graph. Okay. So kana lang, determining lang, karon ga determine pa ta if increasing decreasing ba siya at these intervals. Later on makabalo na gyud ta class kung ang imuhang mo relate na ta karon sa extrema, pero kani lang sa time emphasize na to ang behavior sa imong function. Okay, the last number you will have kani. Last number ba ni? Yeah. You'll have the rational function. So let's have x squared over 2x minus 1. So get the derivative using quotient tool. Okay, rational man na. So low d high minus high d low over low squared. We get this expression. And then simplify na to gamay. We will get this expression. 2x squared minus 2x all over quantity 2x minus 1 squared. So mo yung emphasize. Since this is a rational number, rational equation, you will have two possibilities sa imong f prime of x. Now, one is that ma-equate na to siya to 0. And the second one is kanus siya ma-undefined. Because again, sa ganito yung rule, we get the critical numbers of a certain function when your f prime of x or when your derivative is either 0 or undefined. Okay, start karon sa kanus ama 0. Kanus sa ganing ma 0 ang imong f prime of x when your numerator is 0. So, it doesn't matter. Oh my gosh. Galino, guys. So, yesterday, naglinog na stop jog ko. So, I'm gonna continue. I think din ako dapit na part. So, we already have the expression for f prime of x, no? So, there are two possible ways to find critical numbers. One is that since we are dealing with rational equation, the first is that we equate the numerator to 0 because this will make the whole expression equal to 0. And the other is for the f prime of x to be undefined, we will equate our denominator to 0. Okay, so there is a first case, which is we equate the numerator to 0. So we get two factors. We have 2x and x minus 1. So we get x is equal to 0 and x is equal to 1 as the critical numbers, no, or the values of x that will make our f prime of x equal to 0. And then we will equate the denominator to 0 because this will make f prime of x be undefined. So we have 2x minus 1 squared is equal to 0. So if you square root both sides, you will get 2x minus 1, then 2x is equal to 1, and then finally x is equal to 1/2. So these three now are the critical numbers na to. So it's very important isunod ninyo class. Though pwede man ninyo siya ma-shuffle, no? Pero pinaka-safe good is isunod gid ninyo ang numbers nga in such a way that when you get or when you define the test intervals, gasunod po siya. So we have 0, 1/2, and 1 because this is a very important part no in getting the test interval. So when you have 0, 1/2, and 1 as critical numbers, you will have 4 test intervals. One is from negative infinity to 0, and then between 0 and 1/2, and then between 1/2 and 1, and then 1 to positive infinity. So ingani siya pagtunga sa um imuhang graph, okay? So let's go to the first test interval. From negative infinity to 0, pwede ta mag-set -1 na itong test value. So we will get the f prime of -1, which is, wala lang ako na substitute the class, pero wala siya nga value sa x. So we'll get 4/9, which is a positive value greater than 0. So it is increasing. Okay? So kung tanaw na to diri nga part sa to ang test interval, negative infinity to 0, increasing gid ang imuhang graph or imong function. So between 0 and 1/2, magkuha ta dirag 1/4 may x. So f prime of 1/4 is -3/2. That is a negative value. So that means it is decreasing. So kani nga interval. So you can see it is decreasing. Okay, dili na siya diri na siya tama, no? From 0 to 1/2 na dahil. So 0 to kaning blue. Okay? So decreasing ka na siya. Okay, how about from 1/2 to 1? So we get 3/4 nga value, test value. We have f prime of 3/4, that is -3/2. So negative value yapon decreasing. So sa kini daw nga interval, decreasing daw siya. Okay, so we can see that decreasing na siya nila. Alright, and then finally, sa atong last nga interval, 1 to positive infinity ka na. 2 atong giset nga test value. So f prime of 2 is 4/9. That is a positive value. So increasing. So nakita na to nga diri nga interval increasing ang ato ang function. Alright, so ingana pag define or pag pangita class sa behaviors imong function at different intervals, no? Between your critical numbers. Again, we are focusing on open intervals here, no, as opposed sa atong gisolve before nga closed interval. Okay, let's go to the first derivative test. And this is very much related sa kaning discussion to increasing and decreasing. Kini lang sa first derivative test, mas general siya approach in the sense that we are also getting or we are also distinguishing asa ang imong relative extrema, relative minimum and relative maximum. So, basically class ang yang pasabot diri is sa first derivative test, we get from the word first derivative, we get the first derivative of our function. Just like sa atong gipapangita diri, di ba? We get the first derivative, okay? And then base ana gipangita na to ang sign sa ato ang f prime of x with different test values sa different intervals so that we can conclude kung increasing ba siya or decreasing. So, just to add something to that process, ang atong buhaton is if we have changes no sa ato ang f prime of x, which is the derivative, if it changes from negative to positive, then f has a relative minimum at cf of c. Kasi pasabot ani from negative to positive. Di ba when you say negative, f prime of x, ga-decrease ang imuhang function, okay? And then ningon siya negative to positive. Positive will be paana. Pasaka po ang imuhang function. So pasabot ana, if it changes daw from negative to positive, kana imong critical number diha class nga atong gi-set as one of our endpoints sa interval, that is a relative minimum. No? Maklaro man, kung gikan siya, ni paubos siya, tas nisaka siya, meaning kanang imong point dira, it's a relative minimum. Okay? Second, if it changes from positive to negative, meaning nag-increase siya tapos aya siya ni decrease, meaning kana imong critical number diha nga gi-define C mo na ang imong relative maximum. So pinakataas siya nga value. Okay? Now, if f prime of x is positive on both sides of c or negative on both sides of c, then f of c is neither a relative minimum nor a relative maximum. So, unsa nga man nga mga cases, class? Na mga cases nga ni, okay? So, ato sa ta sa first, no? If, unsa ito giingon ganina, if your f prime of x daw changes from negative to positive, gana siya negative to positive, then, ang imuhang c f of c, ang imuhang f of c mo na siya, no? Okay? Kani siya nga point is c f of c is your relative minimum o pinakaubos mo nga value. Kung positive po siya, changes from positive to negative, meaning kanay mo ang maximum. So the third condition is that when it changes from positive or negative on both sides, dili siya minimum, dili sad siya maximum. Okay? So, natin may example before nung nakaingana lang siya. Nga nung critical number ni siya, ma'am, kung parehas sa rin ang ga-increase, di ba? Ang ato manggong usually yung gakakita sa mga function nga ni change siya between your critical numbers is it's either gaana ra gyud siya or gaana, di ba? So in this case, pareha man siya increasing. Pareha siya increasing. It's just that at this point class, sa imong critical number, nag-change siya ba? Na-ay changes sa behavior sa imong function. Nga ni-change siya at this point. Okay? But it doesn't mean that the changes are totally opposite. Okay? Ni-change lang siya. Diba? Nas nakita ninyo ni Ana siya. Tapos ayan na po siya ni smooth and dira. Okay? But this is considered as your critical number. Nga naman, because at this point, your derivative is 0. Na. Okay? Kika na siya is, imong tangent line na class kay naka-horizontal man. Okay? And same gyapon ani, negative siya. Nya paglabay sa critical number, ni decrease ra gyapon siya, okay? So dili nimo ni ma-consider nga relative maximum or relative minimum because both of the behavior of the function sa iyang left o sa iyang right sa critical number are the same nga it's either increasing or decreasing. Pero again, critical number siya because this is the point of your graph where it changes its behavior. And also, imuhang f prime of x at this point is equal to 0. Okay, so tanaw na ninyo class. Para sa ani, oh. Kung wala ka katanaw sa graph, ani, okay, para sa ani, nga graph. Okay, kung wala ka nagtanaw sa graph, kung nag-assume ta diri increasing man yang ato ang kuano, so pwede na to i-visualize siguro gamay kung ano siya increasing. Ya kana decreasing. Okay, so kung increasing ni tapos decreasing ni nga kuan nga part sa imong graph, so meaning kini nga point kini ding 0 diri di ay is a relative maximum. Okay? Ana man ang iyahang kuan. Kaysa 0 man na siya magtagbo, di ba class? Okay? Nya kini po siya decreasing po siya, decreasing unya increasing. So meaning kaning imong 1 diri, okay, this is a relative minimum. Okay? Again, nagtagbo man na siya di sa 1, kini po nagtagbo siya sa imong 0. Kini sa imong 1. Pero karon between ani nga interval class, unsa man ninyo ma-conclude? Decreasing, decreasing. So wala kay ma-conclude sa imong 1/2. Actually, it is because again, this is neither ni siya. Pwede ani, pwede na ito ma-assume nga ani siya ga-decrease niya, ga-decrease. Pero, ano to sa graph, critical number siya because this part of your graph here and this one is approaching to a value nga 1/2. Pero not really touching, so asymptotic siya. And 1/2 is not part of the domain. Dili siya part sa domain sa imuhang f of x. Nga naman, because this will make this 1/2 here, kung ato sa substitute sa x, this will become undefined because ang imong denominator will be 0. Okay? So ang 1/2, dili siya part sa imong domain. So there are many ways to check class whether or not your critical number is part of the domain. Okay? So, okay, ato ta sa first example na to para mas nasagtan. Okay. So, gamiton gyapon nato class ang ato ang na-learn diri sa atong increasing decreasing function pero mag-add na lang ta karon og conclusion kung relative minimum siya or relative maximum. Sige, we have this example. So we have x squared minus 4 quantity x squared minus 4 raised to 2/3. So we will find first the derivative. So by the virtue of general power rule, muna ito makuha nga expression sa f prime of x. So since again we're dealing with rational function, ato siyang
Atong pangitaon niyang kuan class. Gari na lang ha, taas gamay. Okay. First is that, what are the values of x that will make f prime of x equal to 0? And what are the values of x that will make f prime of x be undefined? So first is, ang numerator na may equate to 0. So we will get x is equal to 0. And then equate the denominator to 0. So we will get kaning a value. So x squared is equal to 4. Again, imong imong exponent is an even number. So you will have two roots, positive and negative 2. Okay, so based atong nakuha critical numbers, there are three critical numbers. We have negative 2, we have 0, and positive 2. Kung atong isunod sa atong number line. So you will get 4 test intervals. Okay? So naatay from 0 to negative 2, kanang interval. We have negative 2 to 0 kaning interval. Okay? We have 0 to positive 2 kaning interval. Kana. And then, you have 2 to positive infinity kaning interval. Okay, kana. Okay, so again, we'll get test value. So katulad pinakaduol nga value class, between aning interval, we can get negative 3. And then getting the f prime of negative 3, wala na lang niya gibutang, tinapulan mo na siya class. So wala siya gibutang value dire, pero yung nakuha nga value is a negative value. Kung atong i-input dire sa ato ang kining expression na to. Okay? So we will get a negative value, and that is decreasing. So nakita na to sa graph, decreasing. Okay? Butang lang na to class, wala sa tanag na graph. Pag mag-visualize sa ta, oy, decreasing siya. So butang sa tagana. Okay? Kani siya is from negative 2 to 0, ang atong test value is negative 1. We will get f prime of negative 1, a positive value that is greater than 0, so increasing. So pwede ta mag-visualize, okay, paana siya pa-increase. So, unsa man nimo before ta mo go to the next interval class, ang atong conclusion diri class sa kini nga two test intervals ba. Since it is decreasing, unya pa-increase siya pod, ang in between nga critical value nato is negative 2, di ba? So meaning, we can assume that our negative 2 here is, so manindot nga color green na lang. So kaning negative 2 din nato, from decreasing to increasing. So meaning, that is a relative minimum. Okay? And then next, we have the next interval, 0 to 2, atong test value is 1. So f prime of 1 is a negative value. So it is decreasing. So decreasing pa na siya. Oy, ang isa increasing, ang isa niya kakuan. Ang before niya interval is increasing. Yung sunod nga interval decreasing. So what can you conclude sa atong value sa 2? Sorry, 0 dahil kaning 0. Okay, kini nga critical number 0 na in between man na siya ana nga interval. So meaning 0 must be a relative maximum. Okay? Next interval. Next interval is 2 to positive infinity. Atong test value is 3. So f prime of 3, nakuha na to positive value class, it is increasing. So mag-draw na po ta og visualization. Oy, increasing siya. Okay, so ang tapad na nga interval ga-decrease. Ang next interval ga-increase. So ang imuhang conclusion karon sa na in between nga critical number, which is kining 2 is, this is a relative minimum. Okay? Okay? Decrease na siya, nya ga-increase. So kutaan to sa graph class, again, wala ta kabalo sa unsa gi itsura sa graph, no? Kanang perfect yun nga itsura sa graph if we just solve mathematically. Pero pwede na ta mag-conclude nga mo na jud ni ang negative 2 nimo mo nimo relative minimum. Pero again, kung sa nimo ang iyahang y value ani ha, equivalent nga y value sa imuhang x. Okay, so karon tanaw na to ang graph, okay? We have a decreasing function behavior no sa first interval. Second interval increasing. So meaning kaning 0 dire, sorry, negative 2 is a relative minimum. Mo ni atong na-conclude based ani nga duha ka interval. Okay? And then the equivalent y value niya is 0. Kung atong i-input ang negative 2 here sa atong original function, then we will get a value of 0. Next interval na to is increasing, decreasing. Kani siya, increasing, decreasing. So kaning 0 din na to dire is a relative maximum. Just like sa atong na-conclude. So relative maximum, ang equivalent niyang y value is cube root of 16. And then next, kanina po you have a decreasing behavior and then increasing na din sa last ni mga interval. So, 2, 0 must be a relative minimum. So, just like sa tong na-conclude dira. Okay, so that's how you get the relative extrema using the first derivative test. So let's solve this one class. Duha lang ka buok. One is a polynomial and then the other is a rational. And then find the relative extreme of the function if any. Ninyo siya if any because I think na-emphasize na ako ni class during the first discussion sa polynomial curves that if you have an open interval, wala jud kay gi-consider nga closed interval ba. It's possible nga wala kay relative extrema. Okay? Sige, let's have this one. Okay, first is x cubed. So first, we get the derivative. We have 3x squared. And then, equate na to 0 because that's the only way to find the critical number. And then we get x is equal to 0, which is isa na tong critical number. X is equal to 0. So, kung isa na tong critical number, then we have two test intervals. Okay? One is katong left sa imong 0, which is from your negative infinity to 0. And then the other is sa right part sa imong 0, which is your 0 to positive infinity. Okay, atong test values, -1 for the first interval. So, 0 man, ikajat lang class ha. Ato ning i-change. I think ako na-upload sa PDF kay 0. Pero, sakto man ang answer, pero ang pag-substitute lang sa value diri class, wala guro na ako na-charge. So, paki-change na lang ko ani. I think sayop to akong gibutang jud. So this should be -1 and this should be 1, okay? And the answer is same naman. If you have -1, f from -1, diri ni may substitute, that is a positive value which is 3. So increasing atong conclusion. And then, sa second interval 1, 3 gyapon tong value, increasing gyapon. So kani siya ga-increase, kani siya ga-increase. So ang kaning 0 dili nato ni ma-consider nga relative minimum or maximum. So atong tanawon class, tanawon sa po na to ang value sa y ni at x is equal to 0. So f of 0, dili na to i-substitute, 0 ang ihang y. So, kini nga point nga 0, 0, it's neither a relative minimum nor a maximum. Therefore, based ani nga function class, ang ato ra dyong ma-conclude is that it has no relative extrema. Pero, mo na akong gipakita ganina no sa first katong graph ba kini. Mo na siya isa ka example sa left side sa imong critical number and sa right side, both of the behaviors of the functions are increasing. So, ga-increase siya. Pero critical number na siya, no? So, though, natay critical number nga nakuha, pero dili necessary nga kuha na siya, extremum na siya. Okay? So, again, it's not a relative minimum nor a relative maximum. Okay? But atong proof na mathematical is kani, increasing siya. So, based sa theorem sa first derivative test, di na to na ma-consider as an extremum. Okay, the last example here, we have a rational function. So, we have x to the 4th plus 1 over x squared. So, using quotient rule to find the derivative, diretso na lang tanong, we will get a derivative of 2x to the 4th minus 2 over x cubed. So, again, kini siya equate to 0 para ma-0 ang f prime of x. And then, kini siya equate to 0 para mahimo siyang undefined. So, we get a value of, from this first case, no, we get kani, x to the 4th is equal to 1. So, that is an even exponent. Therefore, ang imong root, class will be, root sa imong 1, kay positive and negative 1. So, plus minus 1. For the undefined, kani, denominator equate to 0, so you will get 0 nga value. Okay. So, tulo atong critical numbers. We have -1, 0, and 1. Okay. So, again, not minding the graph first, ato sa tanan, itabulate sa nato class. Okay, na kay mga note dire. Sige. Let's have the 3 intervals, no? 4 intervals, kay 3 critical numbers. We have -infinity to -1. We have -1 to 0. We have 0, 1, and then 1 to positive infinity. So, subot sa ta sa first interval. Kung na itong atas value, -2. Okay. F prime of -2, diri ni siya again, i-substitute. Kaya uban ra ba sa original function ma-substitute. So, F prime of -2, we get a value of -15 over 4. So, negative. Ang ato ang conclusion ana is decreasing. So pa-decrease butang-butang ano din mag-ana para dili ka para nakay guide ba. Okay. So next interval 1 0 magkuha ta diri negative 1/2. Sorry, negative 1 0. Negative 1/2. So f prime of negative 1/2 we get a positive value, positive 15. So increasing. So pwede na to sulatan increasing. So before ka mo move sa imong next class, next nga interval, pwede naman ka mag-conclude, oy, decreasing ni, dayon kini increasing, negative 1 must be, ano siya, negative 1. It is a relative minimum. Okay? Pero later, kung na po na to yung y value, ana. Okay, next interval na to, kaning 0 to 1, magkuha tag 1/2 na test value. F prime of 1/2 is negative 15. So it is decreasing. Okay, so decreasing naman eh. Decreasing. Decreasing. So kani decreasing. So before ta magkuan class, di ba sa iyang previous is increasing man no. Unya sa iyang next interval kay decreasing. So again, ato sa butangan og assumption naman ni natong relative minimum diri no, di pa man ni conclusion. Kining relative minimum is ga-assume patatungod sa behavior sa ato ang graph. Pero ato nang i-assume karon nga ang zero di ay okay, zero must be based sa itong assumption, it could be a relative maximum. Tungod ani. Tungod sa atong nakita nga increasing, decreasing. Pero ato pa man i-verify later kung part ba siya karon sa domain. Kaganina man good, nag-assume naman ko diretso eh. Pero anyways, makita man nato kaganina. Pag substitute nato karon sa x value sa atong original function, kung nag-undefine na siya, meaning dili na siya part sa imong domain. So dili igid na nimo ma-consider nga relative minimum or maximum. Sige, balik sa dire. So again, natay assumption no nga tungod ani decreasing, increasing, relative minimum nato ni negative 1, critical number. Tungod ani increasing o decreasing pod, tungod aning two test intervals na to, atong ma-assume nga 0 must be a relative maximum. Okay? Next. Ang next ato nga interval last na lang 1 to positive infinity, so test value nato 2. So f prime of 2 is positive 15/4 increasing. So increasing bana day siya. Okay. So karon ang yang previous nga interval decreasing man, nya increasing na dayon sa kining nga interval. So meaning kining 1 na critical number, kining 1 dire, we can assume that it is a relative minimum. So kano sa na dayon ta maka conclude if sakto tong assumption class. Pangitaon na to karon ang y value. Okay? Nag-assume ta nga ang negative 1 is a relative minimum. Okay? So unsa di value karon sa f of negative 1, meaning the y kini ba sa original function nato. So we get f of negative 1 as 2. So kini ding 1 2 diri is a relative minimum. Now based sa graph sakto, correct, it is a relative minimum. Okay. Karon next, ang atong 0 gi-assume na to as relative maximum. So relative maximum, x is equal to 0. If we substitute it here, f of 0, we will get an undefined value. Okay? Undefined value. So meaning, ang atong gi-assume dira nga relative maximum, dili day siya relative maximum. Nga naman, kay dili siya part day sa imuhang domain. Okay? So karon nara diring 0, di ba? Na diring 0. So asa di karon ang f of 0? It is undefined. Nga naman, kay kung ato pa dyan ng subayon diya class, ato ng sumpayon dira, mo asymptote pud ni siya sa imuhang, asymptotic pud ni siya sa imuhang y-axis, no? Kaning sa 0 nimo. Okay? So again, kining critical number, nag-critical number siya, it's not because nag-change imuhang behavior sa graph, but it's because your graph is asymptotic to this value. It's a very important value. Okay? So, mo na to, atong assumption nga relative maximum, dili day siya relative maximum. Okay, dili siya part sa domain. Next, ang atong 1, gi-assume nga relative minimum tungod sa behavior sa imong intervals, no? So, atong tanawon karon. At x is equal to 1, y is equal to 2. So, meaning 1, 2. At point 1, 2, it is a relative minimum. And it is indeed a relative minimum. So, sakto atong assumption. Sakto. Duha. Okay? So, ang ato lang ma-conclude class is that negative 1 and 2 is the relative minimum. Kana? And 1, 2 is a relative minimum based sa atohang first derivative test. And nasad ko yung note diri. Based on this test, we can assume that x is equal to 0 is a possible, ningon ko diri, is a possible relative maximum. No? Again, tungod sa atong nakita nga behavior sa intervals. Okay? interval nga nasa yung left o right sa critical number. Pero f of 0 will yield an undefined result. Okay, so it means that x is equal to 0 is not part of the domain of f of x. Therefore, it's not an extremum. So yung nga na lang class. So dili siya ingon nga follow gyud mo nga kana jud siya sample kani ba? Man to. Kini. Ningon siya diri nga from positive to negative. Di ba? Ana man to, ini-increase siya, ni-decrease siya. So C must be a maximum. Maximum na. Pero again, dili siya mo follow nga nga na gyud because you have to check pa if C is part of the domain of F. Okay? So there are many ways ba? So there are many ways to check kung relative minimum ba siya or maximum. Okay, so I think that's it. There are so many functions in the world that exist. So pwede nyo isolve na tanan para ma-practice mo on how to get the relative extrema using the first derivative test. So medyo taas lang siya, no? Pero the more ka magbalik-balik, the more ka mag-solve class, murag ma-embed na siya sa imong mind until such time, murag easy na siya for you. Murag na siya muscle memory ba? Murag mong mag-bike bitaw. At first, it's difficult kay mag-balance mo. Pero the more nga sige kag bike, the more nga ma-retain siya sa imong muscle. So murag muscle memory nun din. Nga dili na ka need magkuan pa magbalance magyapon ka no kanang kadugayan nga magbike ka, pero again embed na siya sa imong body, muscle memory na lang siya. Okay, so muna akong advice sa inyo, solve until such time nga muna na lang kinaon ninyo ang kining first derivative test. Okay, kinapatay gitawag pag i-class ng second derivative test. That will be our next lecture. So thank you for listening and answer your take-home quiz. Right now, as I'm recording this, wala po ko na sa inyong take-home quiz, but later siguro na ako'y mahatag sa inyo. So that's all, and study hard and solve. Asan mo kumanto? So balik ako sa Zoom.